Good morning. This is the NASA Mars Lander final report for the first year engineering lab, section 8, fall 2025. And we are the Over Easy Engineering Company. So the basic overview is we're going to include introductions, background, requirements, final design, manufacturing activity, test results, and conclusion. So that basically covers each and every aspect of the project. Right here is our team. My name is Shivraj Patel, and I'm the project manager.
My name is Drew Brock, and I'm the construction manager.
My name is Alexandra Morgado, and I'm the verification and test manager.
And this is the team for our Over Easy Engineering Company. Right here is the RFP that NASA provided us. And this slide covers the customer requirements. So the first requirement is the Mars lander shall deliver astronauts to the surface of Mars. The performance shall be demonstrated during video recorded test on launch day. The Mars lander shall carry two pilots, which are eggs. And the Mars lander has also to be made in a way that is reusable. For the contractor requirements, the Mars lander shall deliver astronauts to the surface of Mars. It must survive a 11-foot drop. It also has to cost $15 or less. It must include a central shock absorbing cabin. It must have a rigid outer layer. It also has to weigh less than 200 grams, and it must maintain an upright orientation using a symmetric design.
This is the final design that our team came up with. We were battling between using a pyramid structure, but we decided that this one would be easier to make and more effective. If you see, the black lines represent the outer cardboard box, the red lines represent the rubber bands, which are shock absorbing rubber bands. The center is a blue circle, which represents bubble wrap loaded with cotton balls, which holds the two eggs. These are the materials we used for our project. One 2 by 2 foot piece of cardboard, 1 square foot sheet of bubble wrap, 20 rubber bands, 20 cotton balls, and one kitchen sponge. And these are all of our materials. And this was our construction plan. We started with a few steps to cut the cardboard box to size for the outer shell so we could form around it. We cut slits along the inside walls to attach rubber bands. We stretched it in multiple directions to create a sort of lattice to form a suspension web. Filled the inner capsule using bubble wrap, cotton balls, and a sponge. Then we placed the capsule in the center so it doesn't touch any walls, and then we adjusted the tension to center it. We sealed the box and then performed the test drop. During construction, we noticed that the stretched rubber bands kept slipping off the cardboard edges. To fix this, we tied an additional rubber band from the outside of the box to lock each stretched rubber band in place so it wouldn't detach during impact. This improved stability, kept the suspension system centered. Toward the end of the build, we were short on time, so we skipped adding a few of the extra rubber bands we had originally planned. This actually worked out well because our core design was already engineered to handle higher forces and the suspension system still strongly performed during testing. And this is what our box looked like.
So these were our lander vehicle test plan results. So our length was 22 centimeters, our width was 15 centimeters, and our height was 13.5 centimeters. We finished the construction of the shuttle correctly. However, when it came time to load, we took 62 seconds to load the eggs, which was over the allotted time. Um, and then when we dropped it, the pilots were ejected. These are the video results. As you can see from the video, the eggs did survive the drop, and you can see that further demonstrated here. So, although the box did break open after it was dropped, the eggs did survive, which demonstrated that our construction plan was very solid, other than the fact that the box did open.
So for the design, it was centered around a cardboard box because it is lightweight and flexible. Inside, we created a suspension system entirely of rubber bands, which was intended to mimic the effect of a trampoline. In the center of the suspended area, we placed a sponge with cutout holes for the eggs and wrapped it in cotton balls and bubble wrap. This design was intended to absorb all the impact, with the rubber bands and the cushioning around the eggs was made so it would be safe if any energy was not absorbed properly. For the assembly, first we had to form our cardboard sheet into a box so we could suspend the eggs in the center. We then started tying and knotting the rubber bands so they stretched from corner to corner. We then cut holes in the side so we would have multiple rubber bands supporting the carrier from every angle. As we progressed, adding more rubber bands, they began to snap out of position. So we had to tie more rubber bands around the outside to prevent them from slipping through the holes and snapping off. The carrier was designed by cutting out holes based on the proportions of the test dummy eggs. And we wrapped it in bubble wrap and cotton balls. We then placed the carrier in the center of a rubber band lattice-like structure. For the results, we had planned for the real eggs to represent the test eggs. Unfortunately, the real eggs were larger than the test eggs, which we had designed our lander for. This led to complications in the loading process, as we were unable to close our carrier in the allotted time. We were also unable to close the outer box, so as a result, both of our eggs were ejected from the lander upon impact. However, both our eggs survived the impact with no damage, which is a result of a well-made design. For the rework and redesign, for potential improvements and redesigns, we would benefit from a much larger carrier compartment for the eggs. Since we were unable to load the carrier properly with the size we had built, we weren't able to properly demonstrate the capabilities of our lander. In hindsight, the rubber band structure on the interior was very difficult to create in the moment, leading us to improvise and tie more rubber bands around the ends to prevent them from snapping out of place. If we had known that would be an issue prior to construction, we would have had a way more efficient construction phase.
Overall, we view this project as a success. Not everything went how we intended, but we still learned a lot and we accomplished our goal of keeping the eggs safe. Um,
Yeah, in the beginning, when we were given the project, we did have a short deadline. We came up with a bunch of designs around 10, but then we realized that some of them were not economical, or some of them, might have taken a lot longer to construct. So we did end up with a pyramid structure or the one with the rubber bands that we just saw. We held on to the pyramid structure for quite some time. But then we realized that if we included the lattice rubber band structure on the inside, that's gonna absorb most, if not all, of the impact. And that was the most important part because both the designs could have been completed in the allotted time, but upon our calculations, the one with the rubber bands absorbed a lot more impact. And it was also a easy process to load and unload the pilots.
I just want to say thank you so much for paying attention to our presentation. Any and all questions should be forwarded to overeasyengineeringcompany@gmail.com. Thank you.
Goodbye.